Hello everyone, my name is Vishal and I am excited to share with you this presentation on direct memory access. In this video, we will discussing how DMA works and how it can improve the performance of computer system. DMA is crucial concept in computer science and I hope that this video we will help you better understand its importance and its application. Let's take a moment to review the main topic I will be covering in this presentation. Here the table of contents. Next slide, we will explain what is direct memory access and how it works. Have you ever noticed that when you are using your computer, play a video or transfer a large file, it can sometimes slow down or take a long time? This is because traditional way of transferring data between hardware components and memory can be slow and inefficient. DMA stands for Direct Memory Access, which is a technology used to allow hardware components such as sound cards, network adapters, and graphic cards to access a computer's memory directly without involving the CPU. Traditionally, when hardware component need to access data from the computer's memory, it has to ask the CPU to transfer the data. This can take a significant amount of time and put a heavy load on the CPU, which can cause performance issues. Overall, DMA is important technology for improving the performance and efficiency of modern computer systems, and it is used in a wide range of devices and applications. On this slide, we will dive into the basic operation of DMA, starting with the fact that DMA provides direct access memory. What this means is that instead of going through the CPU, DMA allows hardware devices to transfer data to and from memory directly. This can significantly reduce the amount of time and processing power required to transfer data, making the overall operation much more efficient. The second point about the basic operation of DMA is that it works as a bus master to enable fast data transfer. In simple terms, DMA acts as a controller for data transfer between hardware device and memory, taking over the control of the system bus and handling data transfer directly. The third point about the basic operation of DMA is that it is a method of transferring data between peripherals and memory without using the CPU. This means that DMA provides direct pathway for data transfer between a hardware device and memory without involving the CPU in transfer process. The third point about the basic operation of DMA is that it is a method of transferring data between peripherals and memory without using the CPU. This means that DMA provides direct pathway for data transfer between hardware device and memory without involving the CPU in transfer process. On the next slide, we will take closer look at how input-output to memory normally works. In a typical computer system, the CPU communicates with input-output devices and memory through a system bus, which is a shared communication pathway that connects all the components. When an input-output device needs to transfer data to or from memory, it sends a request to the CPU through the system bus. This process of involving the CPU in every input-output can cause performance bottleneck and slow down the overall operation of the system. Additionally, it can put a heavy load on the CPU, reducing its processing power for other tasks. To help overcome these limitations, DMA provides a way for input-output devices to transfer data to and from memory directly without involving the CPU in every operation. As we discussed earlier, this can significantly reduce the amount of time and processing power required to transfer data, making the overall operation much more efficient. The next slide shows how DMA actually works. It allows input-output device to transfer data to and from memory directly without using the CPU in every operation. When an input-output device needs to transfer data to or from memory, it sends a request to the DMA controller. The DMA controller then takes control of the system bus and requests access to the memory subsystem. If the CPU is not currently using in the system bus at that time, it will allow the DMA controller to transfer the data directly between the input-output device and memory without any involvement from the CPU. On this slide, we will talk about two types of DMA transfer: DMA transfer block and cycle stealing. DMA transfer block is a very fast method where the DMA controller is control of the memory bus and can continuously transfer 2 or more data bytes without interruption. Cycle stealing is a different method where DMA controller transfer one word of data at a time and must give up control of the system bus to the CPU after each transfer. This method can slower than DMA transfer block because the CPU must frequently interrupt the data transfer. Overall, the choice between DMA transfer block and cycle stealing depends on the specific needs of the system and the type of data being transferred. DMA transfer block is usually faster for continuous data transfer, while cycle stealing may be more appropriate for systems that require the CPU to remain in control of the system bus most of the time. On this slide, we will discussing the advantages and disadvantages of using DMA. Direct memory access has some benefits that can help make computer system run faster. One of the main advantages is that DMA allows data to move between memory and input-output devices directly without using the CPU. This can help speed up data transfer and free up the CPU to work on the other tasks. Another advantage of using DMA is that it can help move data between memory and input-output devices more quickly, especially important when working with large amount of data that need to be transferred quickly. However, using DMA also has some drawbacks. One of the disadvantages is that when using bus mode data transfer, the CPU may not be able to work on other tasks for a period of time. This can slow down overall performance. Another disadvantage is that using direct memory access requires more power than other method of data transfer. This can be a problem for devices that are provided by batteries or for systems where power use is a concern. On our final slide, we will discussing the conclusion of our presentation. National Instrument has been using DMA hardware and software technology to help achieve high throughput rates and increase system utilization. They do this by using the background mechanism of data transfer that minimize the use of the CPU. Data acquisition users, who are people that collect and analyze data, are very aware of the advantages of background data acquisition. DMA solutions have become very popular in this field because they allow for efficient data transfer while minimizing the workload on the CPU. Thank you for watching our presentation on direct memory access.